This is your trainer Vijay, and as already told about myself, I'm MCT, that is Microsoft Certified Trainer, and I have an experience of around 22 years in teaching different Microsoft product and Cisco products. Along with that, I have done my CCNA, CCNP, I am certified CEH, and I have CISSP also. So we're going to talk about TCP IP here. TCP IP stands for Transmission Control Protocol and Internet Protocol. Now, when we talk about TCP IP or a protocol, so we already discussed that protocol means set of rules. So whenever two devices wants to communicate with each other, they have to follow certain rules. That is known as the protocol here. TCP IP is a very vast, commonly widely used protocol all over the world since the inception of it is as a DoD model in late 60s. We will compare the TCP IP with OSI model in later. Now DoD and DoD department model is Department of Defense, which is also known as TCP IP model, which has got 4 layers in compared to 7 layers of your OSI model. So we can say OSI model is actually the expansion of DoD model or TCP IP model. Now we will continue on this, we'll come back to this later. When we talk about TCP IP, now TCP IP has got 2 versions, version 4 and version 6. We start with version 4 now. TCP IP version is 2 power to 32 bits total, whereas IP version 6 is 2 power to 128. Now we'll start with the IP version 4 first. So IP version 4, here when we talk about 2 power to 32, we are talking about total number of addresses which can be created by using the IP version 4. In IP version 4, for any machine or any device, there are 3 major components or 3 major configurations of TCP IP, of TCP IP. The first one is IP address. When I say IP address, so we can define IP address that it is a unique identification number assigned to each and every device on a subnetwork. We'll explain what is subnetwork later. So when we talk about IP address is unique identification number which is assigned to each and every device on a subnetwork. We can assume IP address, we can imagine IP address as your telephone number. Like your telephone number is unique in your country, similarly IP address has to be unique within a subnetwork. There are many other things also, we will be learning that later. So like your telephone number is required for you to communicate with the other people, where you can speak with each other, when you can share information. Similarly, your devices needs the IP address. So IP address is a unique identification number, we can say. Now, when we say it's a unique identification number, the physical structure of this is it's a 32-bit binary number which has been assigned to 32-bit binary number which is divided into 4 octets. When I say octet means you're talking about 8 bits. So octet is 1, 2, 3, 4, 5, 6, 7, 8 like this. This is one octet where you got 8 bits. When I talk about bits, so we know that 1 and 0 are the bits. So your 32-bit numbers, binary numbers, it means we're talking about 1 and zeros, and they are divided into 4 octet. Now, for example, I can say this is one IP address. We write the IP address in this fashion in a decimal format. So for example, write 192.240.248.252. We write IP address like this. This is in the decimal format of the IP address. This is how we write the IP address. For human being, this is the correct format so that we can read it easily or we can remember it easily. But for your electronic devices, they know only one language, that is binary. So it is actually divided like this. I mean, it has been formatted into 32-bit binary number like this, or we can say it is translated like this. So 8 bits, 8 bits, 8 and 8 like this. So this is, once we convert this, we'll learn this later, how to convert binary to decimal. This will give you the value of this decimal. So this is the IP address, and it is a mandatory component of your TCP IP. The second is subnet mask. Subnet mask, I can define it as it is in conjunction with IP address. It defines which part of IP is network, which is subnetwork, and host. See, what happens that we got one address. For example, you got one address, say you got an address John Smith, 32, 322, say Byron Avenue. This is one address I'm just writing. East Ham, London, UK. So this is one address of a person whose name is John Smith and is living in UK, London. Now, this is one address. When you're sending any message or anything, any letter or anything to this person, John Smith, so you have to give a proper address. Sorry. That address will be having the flat number or the house number and the lane, then the location, the city, and the country like this. So whenever we are writing the address of any person, we know that there are certain fields are there, and it's a predefined format. Predefined formats are there. For example, it will be whenever we are sending any message to any person, we always start with the bottom. We always look at the bottom, that which country it has to go, then which city, then which area, then which street, then building or flat or house number, then the person. So it's a predefined format which we all follow. Similarly, the subnet mask is when I write one IP address. For example, when I write this IP address, so when two devices are going to communicate, say this is one device, this is another device. Okay. So when they are going to communicate, they should know the IP address where they have to send. For example, this is the source, this is the destination. Suppose the IP of destination is this one. Now source has got IP address, for example, 10.1.2.3. This is the IP address of this source machine. So if the source is this computer or this device wants to send some message to this address, so they should know where exactly this is located. So what is the network portion in this? What is the subnetwork? Or what is the exactly host? So that is defined by the subnet mask. Like we have got this format. Similarly, the format for IP address is defined by the subnet mask. So we have got different types of subnet mask in different class that we'll see later. For example, we have got class A subnet mask. We have got class B subnet mask. We have got class C subnet mask. This is class we'll learn later. So these are different subnet masks. So what happens, you combine this, you compare the subnet mask. For example, if I compare this one, 10, 1, 2, 3. So it will tell me that, okay, this portion is the network, this portion is the subnetwork, this portion is the host. So similarly, if I write 192.248.240 and 252, it will be compared with a subnet mask, which you'll see later why I'm comparing with this one. This class C, A, B, all these things are, we'll learn in more detail later. So it will compare that, okay, 255, 255, 255 is the network portion. So it means this part is the network portion and this is the host portion. So this is your host and this is the network. So it means what? That if 10.123 wants to reach at 192.248, 240, 252, so it will understand, okay, I have to go to a network which is starting, which is having address, network address 192.248, 240. And in this network, there is a host 252. So that is the importance of the subnet mask. So with the help of subnet mask only, it will find out that where exactly is the network and where exactly is the subnetwork. The third option, or third component we could say, is default gateway address. Default gateway address. Now this is, third one is, the first two, IP address and subnet mask, is mandatory. The third one is not mandatory. It comes only when you are using a router. Now what is a router? Why it is required? We'll just see it now. See what happens, say for example, this is your switch, a device which is having ports. On these ports you have got your computers connected or devices connected. Okay, now you got another switch. It has got some devices or some computers connected like this. All these machines, or they will have some IP address. For example, it is IP address 10.00.10, it has got 10.00.11 and so on. Here suppose they have got also in same 10.00.100 or so on, like this, 101, 102, 103 and so on. Now what happens if I connect these two switches together? All these devices will be in the same network. At the same time, they will be in the same broadcast domain. When I say broadcast domain, it means what? If a broadcast is happening from this machine or any machine, just for example, this machine is sending one broadcast packet, so it will be heard on each and every device or each and every port in the switches. So if your switches, you have connected more switches together, it will be heard on every port in the whole network, and that will create a big traffic. That is a broadcast traffic. We have got three types of communication. One is unicast, we got multicast, we got broadcast. In version 4, TCP IP version 4, we got these three: unicast, multicast. Unicast is if this machine wants to communicate with this, is a unicast, or this wants to communicate with this, is a unicast, means one to one. Multicast means it will be sending some packet only for a group of computer, okay, more than one, and a group of computers, a group of devices, not to everyone. Broadcast means to everyone. So broadcast traffic makes your network slow. So what happens then, at the same time, you want to make sure that only related or only the signals or the packet, the messages, the communication, if it is going outside your network, for any reason, for example, this is your building 1, this is building 2. So you want building 1, building 2 should communicate with each other, but then there should be some proper restriction, there should be some kind of gate, there should be kind of vigilance, for example. Okay. Now, what will happen here, that say, just for example, if we got 100 students and they all are learning certain different technology, 10 10 students in every batch. So 10 students are learning network, 10 students are learning cybersecurity, 10 are learning Java, 10 are Oracle, like this, different students batches are there and sitting in one big room. And the 10 teachers are teaching them at the same time. So what is going to happen? Nobody will understand what is exactly happening. So that will create that is because a lot of collision is happening between the voices, and then there will be a huge broadcast is happening. To solve this issue, what we do, we create 10 different rooms. We create a partition, we create 10 different rooms. We let the 10 that we allow every batch or every technology people to sit in their respective room, and there will be door obviously. So now whatever the communication is happening, it is happening inside that particular room for the respective technology. So it will not cross to the other room, which will not disturb them. But there will be gate. So if they want to go outside for something, they can use that gate to go outside. Similarly here, if this switch, if suppose we are not using, we are not connecting them together. Say for example, we are not connecting these switches together, right? But we want them to be in same network. Now because they are not in the same network, so what is going to happen? There'll be no broadcast. The broadcast will happen inside this network only and inside this network only. We'll consider this is a room 1, room 2, like that. But then for some reason they want to communicate with each other. For example, this wants to go here. For that we need a device which is known as a router. So router will connect to the switches like this, and these routers will be also connected. Now what will happen, the IP of this interface to which your switches or the devices are connected is known as the default gateway address. Default gateway address here also. So if 10, so just for example, we'll take this is 1.10.0.0.1. So what will happen if any packet which is destined for outside this network, means if it is not inside this network, inside the switch network, the packet will reach at the router, that is the default gateway address. So default gateway address will have the router, and router has got something known as routing table. It's like how to reach at a certain address. So if 10.0.0.10 says I want to go to 10.0.0.100, which is not in the same network, which is in another network, so router has got something known as routing table. It will use that routing table information to find this router where this particular network is located, destination network is located, and then it will forward the packets and forward the communication will start. So these three things are there. Now, so once again, you got IP address, you got subnet mask, you have got default gateway address. Now we have got the IP addresses. As I told you that in IP address we have got IP4 has been divided into certain classes. So we'll talk about that. We have class, and the class depends on the range, that is the value of the first octet. And every class has got a default subnet mask. Network host. We got class A, B, C, D, and E. These are 5 classes in IP version 4. If the value of the first octet is between 1 to 126, so for example, if I'm writing 10, 3, 4, 5, so talking about this is the first octet. So value of the first octet is between 1 to 126, it belongs to class A. So this IP address belongs to class A. If this is class A, the default subnet mask will be 255.0.0.0, and the network portion out of this subnet mask or the class A is the first 255, and the host remaining octet will be used for the host. So now 255 means total 8 bits will be used for the network, and 24 bits will be used for the host. 24 because every octet has got 8 bits, so 8, 8, 8, total 24 bits. Class B 128, 191. If the value of first octet, for example, I'm using this address, this is class B because the address falls between 128 to 191. So 172. So now the default subnet mask for this is 255.255.0.0 and network is 255.255 and the host portion is this one. Now here total 16 bits will be used for the network and 16 bits will be used for the host. Then we have got 192 to 223. Here default subnet mask will be 255.255.255 and 0. So network will be the portion of 2555 here like this. So total 24 bits for the network and you get 8 bits for the host. Class D is 224 to 239, but this is for multicasting, so will be not used in a network. E is for experimental, so this is also not going to be used. Okay, so we talk about class ABC only, and you can see that 127 is not here. So any address starting with 127 is a loopback address. We'll see what is a loopback address. When you ping the local host, the loopback address is going to be checked. So 127 we cannot write in the first octet. So we can say value of every octet is fixed. So value of the first octet will be always between 1 to 223 except 127. Will not have 127 in the first octet. Value of the second and third octet, second, third and 4 we can say will be always between 0 to 255. So why 0? It means suppose you got 8 bits. If the value of all the 8 bits is 0, the decimal value will be 0. If it is all 1, so all the possible values are between 0 to 255. So this is how your addresses will be. Class ABC will be there. Now, after understanding the class, we will come to something known as subnetting. Okay, we talk about private address and public address also. Two types of IP addresses are there: private address and the public address. Private addresses are basically, these addresses are for the addresses which is for enterprises. Now there are reserved private addresses for class A. The reserved private addresses are 10.0.0.0 to 10.255.255.255. For class B it is 172.16.0.0 to 172.31.255 and 255. For class C, the private address is 192.168.0.0 to 192.168.255 and 255. The use of the private address is that, say for example, now if we are not using, there is no there is no concept of private and public address, just assume that. What is going to happen then? That for example, you are working in an organization and you got multiple devices here and you are using any address. Suppose you are using address in your network as 75.123. Now, if you want to connect to a server, web server, and unfortunately, this web server or this website also have got the same address. So there will be conflict through the internet, right? So to avoid this conflict, the private addresses are created. So what happens that these private addresses, anyone can take. Anyone can use these private addresses all over the world inside their organization. So once, suppose now we'll assume that this has got a private address 10.1.1.2. So 10.1.1.2 wants to connect to 75.123. Now what will happen that it will use a router to go outside. This router has got something known as NAT we got network address translator. So a private to public communication will be done through that. That we'll see in more detail later. So that will make sure the addresses are unique on the internet and there is no conflict of the addresses. Apart from that, the private addresses are free, so you are not paying for them. Public addresses are any address apart from these A, B, C ranges are the public address, and we have to pay for these addresses. This is a private and public address. After that, we'll talk about subnetting. Subnetting is the process to divide your network into the subnets. Why we want to subnet our network? Because to control the broadcast. Broadcast traffic could stop your network, could hang your network, could slow down your network, and which ultimately will cause a business loss also for you. So to avoid that, we have got the subnetting processes there. So for the subnetting, what happens that we get a network ID. Say for example, you got a network ID 21000, and your subnets are required based on different criteria parameters. For example, building wise or department wise, you want to create multiple subnets. So the desired subnets you want is 7. So total 7 subnets. To create the subnet, we need the routers. To create the subnets, we require the routers. So we have got subnets and we have got the network ID. This is what we have. Now we have to create the subnetting. For that, we have to use a formula, that is 2 power to n minus 2 is greater than equal to number of desired subnets. So where n is equal to number of bits to be masked. When I say masked, means we are talking about if it is 0, we are going to convert as 1. That is masking. So here in our situation, 2 power to n minus 2, we are going to get 7. We need the 7 subnet. So if I write the value of 2 as 0, I will get 2 power to 0 as 1, which will not equal to or not greater than 7. If I write here 1, so this is 2. So 2 minus 2 will be 0, which is again not equal to 7. So 2 power to 2 is 4. So 4 minus 2 will again not equal to 7. If I take 2 power to 3, that is 8. 8 minus 2 will be not equal to 7 as well. So nearest I will get is 2 power to 6. So 2 power to 4. So 2 power to 4 will give me 16 minus 2, which will be greater than 7. So I cannot take 6 because I'll get value. If I put 2 power to 3 here, I'll get total 6, but I want 7 at least. So I'll go for 2 power to 4. So 2 power to 4 minus 2. So I can say I have achieved this 4. This is the first step you have to get. After getting this value of 4, what we have to do, we have to use this. So as we see that these are the number of bits to be masked. Where we are going to mask? Now we have got the IP. This is the network ID. This network ID has got what we are going to do, any non-zero octet, we are going to write the 255 like this. 1, 2, 3, 4, 5, 6, 7, 8. And the remainings are 0. Like this. Now you are going to, so what you're going to do next is 1, 1, 1. This is going to be same because this is 21s and this is class A. So this is all 1, 255. This is 255. After that 0. So what we are going to do, we are going to use these 40 as 1 here. I mean these 4 bits will be masked here. So the 40 will be converted. The remaining will be 0 also. Now if you convert the value to decimal, we'll get 255. This will be 240 and this will be 0 and this will be 0. This is known as your customized subnet mask. This is known as the customized subnet mask. This is your second step. after getting the customized subnet mask, you'll get this value which has been you got after doing the customization. What you have to do, we got a default base number. In TCP IP, in IP, we have got a base number that is always 256. Why it is 256? Because all the numbers are between 0 to 255. If we count 0 and 255, total number are 256. We are going to subtract this 240 from 256. Whatever value you get here, you might get 248, 252, you might get 254, you get 128, anything you get here, you're going to always subtract with the base number, that is 256. You get 16, that is the range. So that is your third step. After getting this range, we are going to implement this into the subnets. So the range, now we have got this is our network, and we are going to use the customized subnet mask. Okay, a range is of 16. What we are going to do is just write the subnet network ID, valid host IDs, IPs, and we got a broadcast. So what we'll do, we'll simply write subnet number 1, 2, 3, 4, and so on. The network ID is obviously 21 is everywhere, we can check it. All the networks start with 21 because our network is of 21. Okay. Now, after that, we know this customization has happened in the second octet, which we have got range of 16. We're going to write 16 here, 0, 0 as it is. We are going to take it here. After that, what happens here, the second subnet will be whatever the range we have got, we are going to multiply this into the number of subnet, we get 32. 16 multiply 3 is 48. 16 multiply 4 is 64, and so on. 5 will be 80 and so on. So every subnetwork is starting with 21.16.0.0, which is a network ID. Second subnet is starting with 32.0.0.4 like this. Now valid host IP address, from here you'll have the IP addresses. So first IP address will be 1. Always the right hand octet is going to change 1, then it will be 2, 3, 4. It will reach up to 255. Once it reaches this 255, then this octet will change to 1. So 1.0, 1.1, and so on. Once it reaches 255, it will go to 2. So unless it reaches 255, once it reaches to 255, this will change to 17. So this will keep on moving till it reaches to 21. Now this is starting at 32. So this will be 31. And this is maximum is 255 and 254 here, because the last address we are going to use for the broadcast. Broadcast means in this network, in this particular network, in the first subnet, any broadcast will be happening on this particular broadcast ID. For a network, broadcast ID is 255, 255, 255, and 255. That is a network broadcast ID. For every, this is a universal broadcast ID, and for every subnet, you got a separate broadcast ID and network. Similarly, here also we have got 3201, it will start 3201, and 234 up till it will reach at, this is 48, so here it will be 47, 255, and 254, and this will be 221, 47, 255, and 255. Similarly, here we can have 21, 48, 01. This is 64, so here it will be 63, 255, and 254. And this will go to 21, 63, 255, and 255. Now here also we got 21. Now this is 64.0.1 will be the first address, and the last address, so 16, 5 times if we do, it will be 80, the fifth subnet. So we are going to put it 79, 255, and 254. And here also we got 21, 79, 255, and 255. So what happens here, all these IP addresses are valid for all the devices. So all these IP, for example, 21, just for example, if 21.16.19.20 wants to communicate with 21.30.3.4, so they are in the same subnetwork, as you can see. So they will not require a router for communication. They don't require a gate for communication. But if suppose it wants 49.3.4, now the 16 and 49, they are in separate subnet. So then they require a router. And router, usually the first IP address is always given to the router. That is the default gateway address. So they will go to the router to go outside, which is to the other subnet. So this way we create the subnet to control the broadcast, and these are the basic of TCP/IP, IP version 4. We are going to see more options in IP version 6, and we'll have more practice questions, practice subnetting like this. So I hope this clears your fundamental and basic about the IP version 4 and TCP/IP. Thank you very much for watching the video.